Good morning. My name is Katie Frassinelli. On behalf of the California Sanitation Risk Management Authority, CSRMA for short, I'd like to welcome you to this morning's webinar on NFPA 820, the standard for fire protection in wastewater treatment and collection facilities. Just a little bit of background on CSRMA in case you're not familiar with them. CSRMA is a public agency risk-sharing pool that was formed in 1985. They're not an insurance company. They're more like an insurance cooperative made up of over 60 different sanitation districts throughout California. They come together and they pool their risk. Now I'm going to turn it over to Zahir Sheikh. Zahir is a project manager with Carollo Engineers, and he's located out of their Walnut Creek office here in the San Francisco Bay Area. Carollo is the largest firm in the U.S. dedicated solely to water-related engineering, and they have offices throughout the country. So thank you, Zahir, for taking time out to bring everyone up to speed on NFPA 820. During the webinar, if anyone has any questions, go ahead and type them into your GoToWebinar chat window, which you should see on the right side of your screen, and Zahir will address them at the end of the presentation. So I'm going to switch it over here, and Zahir, take it away. Thanks.
Thank you, Katie. Good morning, everybody. Today we will do a brief overview of the NFPA 820 standard, which is a standard for fire protection in wastewater treatment and collection facilities. Like Katie said, Carollo is a big wastewater firm. We do mostly work in the water area. And since we do a lot of wastewater treatment design, we use this standard almost every day. We refer to this standard when we are designing new projects or modification to existing facilities. And on occasion, we have been asked by various clients to do an assessment of their treatment plant to identify any safety issues there might be. So for today's agenda, we will talk about three broad topics. One is we'll talk about before we go into that, I have a couple of colleagues with me here. We have Chris Carvalho, our Chief Electrical Engineer, and Daniel Chien. He's an engineer in my office, and he helped me on quite a few projects with this assessment. So they'll be here to answer any questions when questions come up in the Q&A session. So topics of discussion today: background of NFPA 820. Then we will dive into how to actually use that standard to classify areas within your facility. And then last but not the least, we'll talk about a case study where we were asked by a client to actually do an assessment of the entire treatment plant and find out areas that don't meet the current standard. So for the background, NFPA was developed based on fire and explosion incidents in wastewater treatment facilities. These incidents, even though they were rare, they were severe enough that they caught to the attention, and a standard was developed. Initially in 1990, it was issued, and it was issued as a recommended practice. Later on in 1995, it was changed from recommended practice to an enforceable standard. Then subsequently, I think about every 4 years, they revised the standard. So the latest one came out in 2016. The one before that would be a 2012. So how does NFPA 820 apply, or where does it apply? So it is applicable for wastewater treatment facilities and collection systems, right? But when does it apply? Okay, it applies to all new construction and when improvements or modifications are done in a certain area, right? So if you look at the Article 1.4.1 of the standard, it says that the provision of the standard shall not apply to facilities, equipment, structures, or installations that existed or were approved for construction or installation prior to the effective date of the standard. So anything that was built before when the standard was made a standard, it does not apply, this NFPA 820. And any new work, any new design, construction work that we do now in wastewater treatment and collection facilities, this standard applies. However, there is a little caveat to that. The authority having jurisdiction may apply any portions of the NFPA 820 retroactively. So there is an article 1.4.2 in the standard that says in those cases where the authority having jurisdiction determines that the existing situation presents an unacceptable degree of risk, the authority having jurisdiction shall be permitted to apply retroactively any portions of the standard deemed appropriate. So the authority having jurisdiction for a certain wastewater treatment plant could be the fire marshal of that area, and that fire marshal could look at a certain area inside your wastewater treatment plant and say, there is unacceptable degree of risk in this area. I want you to do some improvements to improve the safety in this area. So it definitely applies to new construction, new design work you're doing, but it can be enforceable on existing structures or existing process areas. So what does NFPA 20 do? The basic function of NFPA 20 is to actually classify the elements of the wastewater treatment and collection facilities. Classify being they assign it to a certain class. There are tables in the standard that helps you identify what is the classification of a certain area. So NFPA 20 provides the hazard classification of specific areas and processes at wastewater treatment plants and its associated collection systems. And what do you do with that classification then? What NEC does is NEC then establishes the requirements for equipment in different classifications. And then to minimize the hazards, the electrical equipment must be designed in accordance with NEC requirements. So you establish a certain area, say a sludge pump station. What is the classification? And then after you establish the classification of that sludge pump station, you would use NEC to see what are the requirements for the electrical equipment that should go in that area. So the National Electric Code groups the hazards into three different classes: Class 1, Class 2, and Class 3. Class 1 deals with flammable vapors and gases. Class 2 is concerned with combustible dust. And Class 3 is all about ignitable fibers and flyings. So flammable gas is a significant hazard in wastewater treatment and collection facilities. There are two primary gases that are flammable that we encounter in wastewater facilities: hydrogen sulfide and methane. Hydrogen sulfide is most prevalent in raw sewage facilities like your sewer pipelines or your sewer wet wells, headworks, primary clarifiers, etc. And methane is most prevalent in sludge handling / digestion facilities like digesters, your sludge thickeners, your sludge storage tanks. So since flammable gases are the major hazard in a wastewater treatment plant, Class 1 is the primary category for wastewater treatment facilities. So the spaces in wastewater treatment and collection facilities fall primarily under Class 1. Then what NEC does is they further classify Class 1 into three more divisions: Division 1, Division 2, and unclassified. So anything where the hazard is present during normal plant operations is put under Division 1. Then Division 2 includes hazards that are present during abnormal plant operation. Like normally, it's nothing's a hazard, but if this is an abnormal thing like a leak in at a valve or something, right? Then it becomes a hazard. The gases coming out of that leak could create a hazardous situation. Then those areas are put in Div 2. And then there are areas that are unclassified because they don't present any hazard during normal operation. So going through the NFPA 820, you would see every process area is either divided or classified as Class 1 Div 1, Class 2, Class 1 Div 2, or Class 1 or unclassified. So you will see these three terminologies repeated throughout in the NFPA 820 standard. Then NEC establishes requirements for electrical equipment for these classes. Like Division 1, if an area is Class 1 Div 1, you would have to use explosion-proof enclosures, and you would need conduit seals at interface between classified and unclassified areas. If a conduit is crossing from an unclassified area to a classified area, you would need a conduit seal in there. Similarly, for Division 2, there are some specific requirements. Explosion-proof enclosures are not required, but you still need and we would still need conduit seals on conduits that pass through classified and unclassified areas. And the unclassified areas, there are no special requirements for electrical equipment. So this basically shows this slide the equipment that would be required for classified spaces. Like a NEMA, the photo shows a NEMA Type 7 enclosure, which is an explosion-proof enclosure. The design allows for an explosion of a certain intensity to be contained within that enclosure and not leave the enclosure. And then also there is a picture of this conduit seal. This is the seal that you would put on your conduits when your conduits cross areas of two different classification, if they cross from a classified area to an unclassified area, so that the gases don't travel inside the conduit from one area to the other area. They're sealed off. So how do explosions or fires occur? For an explosion or fire to occur, flammable gases and vapor concentrations must be within its lower explosion limit and upper explosion limit, combined with an ignition source. Lower explosion limit is concentration of the flammable gas or vapor in air below which the gas atmosphere is not explosive. And similarly, the upper explosion limit is concentrations above which the gas atmosphere is not explosive. So the gas concentration in the atmosphere has to be between these two limits, and there has to be an ignition source for an explosion to occur. So explosion limits of certain gases and vapors commonly found in wastewater treatment plant are shown on this slide. There are four commonly found gases in a wastewater treatment plant or wastewater treatment facility: hydrogen sulfide, natural gas, sewer gases, and sludge gas. And the second column shows the lower explosion limit, and the third column shows the upper explosion limit. So for an example, the hydrogen sulfide, if the concentration in the atmosphere is in between 4 and 44, so if the concentration is 10 and if there is an ignition source, then there is a possibility of an explosion. A couple things about the sewer and the sludge gas. The sewer gas is defined by the US EPA as gas that contains 5% of methane and 25% of other gases. And sludge gas is defined as gas that is 65% methane and 5% other gases. So what are the typical sources of ignition in a wastewater treatment facility? There are sources that are from the equipment itself, and there are from maintenance activity. Like from equipment, it could be the hard surfaces, like the boilers, generators, engines, or stray electric currents from the conductors, wires, and switches, or sometimes mechanically generated sparks from movement of mechanical pieces like the actuators and grinders and pumps. And the mechanical activities like sparking tools or the static electricity could actually create an ignition. So the gas concentrations put together with the source could be a hazard, could produce an explosion. Now let's jump into how to use the standard. So this slide basically gives you a short table of contents for the standard. NFPA 820 consists of 10 chapters and 6 annexes. The chapters are listed on the top and the annexes are listed at the bottom. The chapters 1 to 3 mostly are about administrative stuff, references of the publications and definitions. Chapter 4 deals with collection systems. Chapter 5 deals with liquid stream processes. Chapter 6 with solid treatment processes. Chapter 7 is about fire and explosion prevention. Chapter 8, materials of construction, 9, ventilation, and 10, administrative controls. So as you saw from the TOC, the components of wastewater treatment facilities are grouped under 3 major categories by NFPA 820. They are grouped as collection systems. Group 2 is liquid stream treatment processes, and the group 3 is the solid treatment processes. And under the solids treatment, it is further divided as solids treatment and sludge drying. So what is included in the collection system? Collection system includes off-site facilities related to wastewater, that is stormwater and sewage collection and transport systems. So these would be your wastewater sewer lines, wet wells, lift stations, and structures like that. That is outside the fence of your plant in the collection system. And table 4.2.2 of the standard covers collection system components. Then the second group is the liquid stream treatment processes, which includes on-site facilities related to wastewater liquid treatment. So this would be structures or processes inside the plant fence, treatment plant fence, which would be the headworks or the EQ basins or the primary treatment or the secondary treatment trains. All these structures that deal with the liquids treatment inside a treatment plant are dealt with under the liquid stream treatment processes. And table 5.2.2 of the standard covers liquid treatment system components. And the third group is the solid treatment processes, which includes on-site facilities related to wastewater solids handling and treatment. So these are your treatment processes that deal with the solids, such as the grid and the scum handling from the headworks, the primary and the secondary sludge, your digesters, or any gas handling systems used in solids treatment processes. And then it also includes the sludge drying and sludge storage areas. And table 6.2.2a deals with solids treatment components, and 6.2.2b covers sludge drying components. So this slide basically shows you one of the pages from the 3 or the 4 different tables that you will find in NFPA 820. This page happens to be a page from the solids treatment process. That is a page from table 6.2.2a. And on the next slide, you'll basically see a zoomed in version of that row. So this row 9, basically deals with your sludge pumping station, the dry side of that, the dry well of a sludge pumping station. And over the next few slides, we will go over the process on how to read this table. So what you would do is you would start with the area that you are concerned about. The location, it depends upon the location and function of the area. So you will select the applicable row. So if you go back to that table, there are rows for different areas. This happens to be for the dry side of the wet well. There is this area for maybe it's for the wet side of the wet well. and this area is for primary maybe digester, right? So because it deals with the solids. So you have to go to the table and find the right row based on what is that area's function. So in this case, it is the dry side of a sludge pumping station. And then after that, the next step would be to figure out the ventilation requirements. Ventilation is basically calculated as air changes per hour in the NFPA 820 standard. If you see this table down here, this is the code they use for different ventilation systems. If there is no ventilation, or if it's ventilated at less than 12 air changes per hour, it's A. B is anything that is continuously ventilated at least 12 air changes per hour. C is something that is continuously ventilated at least 6 air changes per hour. And D is there's no ventilation, or if the ventilation is less than 6 air changes per hour. So if you are designing a new system, then you would pick what you need to design the ventilation system for. Maybe you decide that you want to have less than 6 air changes per hour, then you will be using that row. And if you decide, well, I will provide at least 6 air changes per hour, then this row will be applicable to the design. And in cases where you are actually assessing an existing facility, you would calculate your existing air changes and you would see where it fits. Say if you have a sludge pump station dry side, and if you calculated that you have only 4 air changes per hour in that area based on the existing ventilation system, then you would actually be using this row. So the requirements of this row will apply to that area. So one thing to note though is that the ventilation requirements in NFPA 820 do not address the personal protection from toxic effect of exposure to gases. They solely deal with the explosion hazard. They do not address the toxic effects to personal exposure at all. So these air changes are only to keep the explosion hazard, to minimize the explosion hazard, nothing to do with personal exposure. So the next step you would do is you would determine the extent of classified area and NEC classification of that area. So the first column that is actually highlighted actually shows you what is the extent of that classification. It is the entire dry well. The same here, it is the entire dry well. And if you are designing for ventilation D, then the entire dry well is class 1 div 2. And if you are designing for ventilation C, then your entire dry well is unclassified. So electrical equipment that is appropriate for these classes should be designed or should be provided. Then next is the one important thing to note is that the extent of classified area for some facilities may exceed the boundary of the physical structure. So in this case, if the dry well, it says the entire dry well is either division 2 if we have ventilation D, or unclassified if you have ventilation C. But there are instances, there are structures where their classification areas, the extent of classification area actually exceeds their physical boundary. It goes beyond the structure. So there are some examples which will be shown on this slide of classified areas extending beyond the physical boundary. The first example here is the primary sedimentation tank. This is your primary clarifier. Typically, these tanks are not covered. They could be covered for odor control purposes, but in most cases, if they are not covered, then the classification is anything within the tank above the minimum water operating surface is classified as class 1 div 2. And then there's an envelope outside the tank that extends 18 inches above the wall and 18 inches outside the wall. that is a second region that is also classified as class 1 div 2. And then there is a third region which basically extends 10 feet outside the wall at grade level, but 18 inches above grade level. That is class 1 div 2. So the caution with areas like this is if you have another structure within 10 feet of a primary clarifier, then the envelope from this primary clarifier can actually influence the classification of that structure. And then we also have another example here. It's of an anaerobic digester. So as you can see from this figure here, but by the way, these both figures are actually taken from NFPA 20. They have figures like these for illustration to help you understand how to apply the standard and how to classify various treatment processes. So as you can see from the example of the digester, the digester, everything inside the digester itself is a class 1 div 1 area, and then there is that area outside the digester, 5 feet around and 10 feet above the highest point on the lid or dome of the digester. That is also class 1 div 1. And then there is a second area that is outside this class 1 div 1 area that extends 5 feet all around and 15 feet above the class 1 div 1 area, and that area is class 1 div 2. So basically, what would happen here is a certain treatment process or facility's classified area may dictate the classification of the adjacent facility. So that is something to watch for. There is an interaction because in a treatment train, structures are laid pretty close to each other. So it could happen that one structure can influence the classification of the next structure. So that should be kept in mind. And the second last column, NFPA 820 prescribes the material of construction. It says what should be the material of construction. It has to be NC's non-combustible, low combustible, or low flame spread material. You can use any of these materials. In fact, both. It doesn't matter what type of ventilation you have. It looks like from this table, any sludge pumping stations, dry wells should be constructed of these materials. And NFPA 20 also prescribes fire protection measures. From this table for the sludge pumping station dry wells, it looks like you have to provide a hydrant and a fire extinguisher. It doesn't matter what ventilation you're providing, you have to provide a hydrant and a fire extinguisher. So let's talk about a case study now. So we, like I said in the beginning, we do look at this NFPA 820 standard whenever we design anything new. If it's a new construction or even if it's a modification to an existing structure, if we are putting in new electric equipment, we have to look at the standard and design appropriately. But in some cases, some of our clients have actually approached us to actually look at their entire treatment plant and then identify any deficiencies or any safety concerns, the areas that did not meet the NFPA 820 standard, the current NFPA 820 standard. So this is a case study of a client that is actually located in Central Marin County, California, in the San Francisco Bay Area, CMSA. This is a wastewater agency. They started operating in 1985, and their average plant capacity is about 10 MGD. So they approached us and they said, hey, can you look at our entire facility and tell us, identify areas of concern, if any. So in 2014, we were hired to do this assessment and to recommend ventilation improvements throughout the WWTP, towards the wastewater treatment plant. So one way to improve the safety for NFPA 20 is basically ventilation. Ventilation, what it does is it moves the flammable hazardous gases out of the area, and the more you ventilate, the lower risk. So you can actually improve. There are instances or listings in the table where a class 1 area, class 1 div 1 area can be made a class 1 div 2 area by increasing the ventilation. Like you saw in the example of the pump station, the wet well, if it was ventilated less than the dry well of the pump station, if it was ventilated less than 6 air changes per hour, it would be class 1 div 2. But if you bump up the ventilation to 6 air changes or more, then you're unclassified. So the agency said identified areas that could be improved if they currently are not unclassified. And so, and then when we did complete a study, and we identified several improvements which were recommended to the agency. So over the next few slides, what I would do is actually I would talk about the common theme that we saw in some of their areas, the common deficiency, the common issue. So the first one was the ventilation system. In some areas did not meet the requirements of section 9.2.4. Section 9.2.4 basically says all mechanically ventilated spaces shall be served by both supply and exhaust fans. So to ventilate an area, you should have a fan to supply air and a fan to exhaust the air. And the issue in some of the areas at CMSA was they were forced exhaust only in areas. Passive louvers were used in these areas for air supply. So they were missing a supply fan, an air supply fan. So the recommendation basically was to replace the passive louvers with air supply fan to provide mechanical ventilation. And doing this study for our various clients, we have found similar issues with their facilities also. There was a practice back in the 70s and 80s, I guess, where supply fans were typically not provided, louvers were used to supply the air into the room. But the code currently requires that you have to force supply the air and not just rely on louvers pulling in the air because the exhaust fan is pushing the air out. And then another thing we found that was a common theme for most areas was the ventilation system alarm in some areas did not meet the requirements of section 7.5.1. And section 7.5.1, what it does is it says all ventilation systems that are used to reduce the classification of a space shall be fitted with flow detection devices connected to alarm signaling systems to signal local and remote to indicate inadequate ventilation and ventilation system failure. So the issue we found was in some cases there was no instrumentation to alarm if somebody turned off the ventilation system or if it stopped working. So the standard really requires the ventilation system for certain classification to keep the hazardous gases out, right? So if the fans stop working, now the gases start accumulating in that area, and that is not good for the equipment. Then it is actually exceeding what the equipment was designed for. The atmosphere is not the right atmosphere at that point. So it is really important that if you're using a ventilation system to kind of declassify or lower the classification, like in the case of the sludge pump station dry well, right? If we said, oh, I'm going to provide 6 air changes per hour, and I would then my area will be unclassified, then I won't have to provide equipment that is suitable for class 1 div 2. Then if you turn off the ventilation system, now you don't have that 6 air changes per hour. So the classification of that room changes to class 1 div 2, but you have equipment that is not suitable for class 1 div 2. So to prevent or to avoid such circumstances, the code says you have to have an alarm that tells you that the ventilation system has stopped working, either because it has failed or somebody has stopped it, somebody has turned it off. And our recommendation for CMSA and other agencies that we dealt with doing similar studies was to add flow switches and wire them up to their PLC and provide an alarm at the SCADA, as well as at the same time provide a local alarm saying ventilation system failed, there is no ventilation in this room anymore. And another type of commonly found issue we find is the source of the supply air in some areas did not meet the requirements of section 9.3.1.1. And that section basically says the air changes per hour shall be based on 100% outside supply air, which shall be exhausted. So what the standard is saying is your air that you're using to calculate your air changes per hour, that supply should be 100% outside supply air from the atmosphere. And what we found was in some areas, the ventilation system intakes were located in the class 1 div 2 envelope of the adjacent area. The structures were so close by that the intake happened to be in class 1 div 2 envelope of an adjacent area. So some of the areas then did not satisfy the requirements of 9.3.1.1. So basically what that does is you're actually pulling in the gases that were being exhausted by this other area. So you're not bringing in fresh air to purge your room, but you're actually bringing in hazardous air, and you might end up concentrating the gases in this room now. And the recommendation basically was very simple. It was to relocate the ventilation system intakes, put them in a location where they are not influenced by the classification envelopes of the adjacent area, but where they would actually pull in a lot of fresh air as required, 100% fresh air as required by the standard section 9.3.1.1. So, and before we get into the questions, there are some other requirements of NFPA 820 that I have not mentioned here, but there are requirements like every ventilation system that is larger than 2,000 SCFM should actually have smoke and fire dampers, or requirements like if your ventilation system should actually be supplied with a standby power system, a second power source. If the primary power source fails, then you should switch automatically to the secondary power source. So there are other requirements, but mostly the agencies that we helped do the assessment, they had those features already built in, and they were good on that part. With that, I would like to open up the webinar for questions.
Great, thanks, Zahir. So everyone should have a GoToWebinar screen there. If you have any questions, go ahead and type them right in. We have a few minutes left. Also, we're going to email the slides out later today, so look for those in email. And if you want to share the webinar with any of your colleagues, we'll be putting it up online in the next couple of days, so we'll also send you a link in email as well. So I don't see any questions. Zahir, do you have anything else you want to add?
Sure. Yeah. One last thing. If you think about any other questions, feel free to contact me. This is my contact information. I am located in Walnut Creek. And the slide also shows my mobile number and my office cell, office number, and my email address. So any questions you might have, please feel free to contact me.
Great. Thank you so much. I appreciate you sharing your expertise with us. And thank you everyone else for your time today, and have a great day.
Thank you.